Hi friends, hello, how are you? At first let me begin with a little ice breaking. See here, there are different types of commodities and their prices. They are arranged in rows and columns. Have you observed anytime your progress report? In that how the marks are arranged? They are arranged in rows and columns. And have you observed any for your cell phone? In that the numbers are arranged in rows and columns. And have you ever went to ration shop? There the prices are arranged in rows and columns. So the arrangement of numbers in rows and columns is called matrices. Now we are going to discuss about matrices. As we know, we have already learnt in 9th class what is a matrix. A matrix is the arrangement of elements in a rows and columns either in a rectangular form or horizontal form. It is a matrix, and we have learnt different types of matrices and operations of matrices such as addition, multiplication, subtraction, and now we are going to discuss about multiplication of matrix and finding the inverse of matrix, and to solve a linear equations into two variables. You have learnt in 9th class types of matrices. Let us recall in glance. See, first matrix is the arrangement of elements in rows and columns. There are different types of matrices. Let us see some matrices. First is square matrix. Square matrix. In this square matrix, the number of rows is equal to the number of columns, then it is called square matrix. For example, A equal to 2, 0, 0, 2. This is here. Before knowing that, what is the order of matrix? Here, how many rows? 2 rows. And how many columns? 2 columns. Here, the order of matrix is rows by column. The rows and columns. Here, the order of matrix is 2 by 2 matrix. Here the order of matrix is equal. So it is a square matrix. The number of rows is equal to the number of columns. It is a square matrix. Let us next see rectangular matrix. In a rectangular matrix, the number of rows is not equal to the number of columns, then it is called rectangular matrix. Did you understand? The number of rows is not equal to the number of columns, then it is called rectangular matrix. For example, B equal to 1, 2, 3, 4, 5, 6. Here how many rows? 2 rows. How many columns? 3 columns. So here the order of matrix is 2 by 3. They are not equal. So it is a rectangular matrix. Next, row matrix. Row means the horizontal way is called row. When the numbers are arranged in only one row, it is called row matrix. Row matrix. For example, row matrix A equal to 1, 2, 3, 4. Here how many rows? Only one row. How many columns? 4 columns. Here the order of matrix is 1 by 4. So it is a row matrix. Next we will see a column matrix. What is column matrix? The vertical line is called column. When the arrangement of elements in only one column, it is called column matrix. For example, A equal to 1, 2, 3. Here how many rows? 3 rows. How many columns? 1 column. The column matrix is only 1. Here the order of matrix is 3 by 1. It is a column matrix. Next, zero matrix or null matrix. By listening zero matrix or null matrix, you can understand what is zero matrix and null matrix. Let us see what is zero matrix and null matrix. Zero or null matrix. Every element should be 0. So it is a null matrix. For example, 0, 0, 0, 0. In this matrix, the every element is 0. So it is a zero matrix. Next, principal diagonal. It is very important. Listen carefully. Principal diagonal matrix. Principal diagonal matrix means in a matrix the elements from the first row, from that last row, in elements from the first row, first column, from that last row, last column, it is principal diagonal. For example, A equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. Here the principal diagonal means the elements from the first row, first column, from that last row, last column. It is a principal diagonal matrix. The sum of these principal diagonal matrix is trace of matrix. See here, what is the sum of principal diagonal? 1 plus 5 plus 9 equal to 15. What is this? The trace of matrix. The sum of the principal diagonal is trace of matrix. Next, scalar matrix. In scalar matrix, the elements which are in principal diagonal is equal and the rest of the other are 0. Then it is called scalar matrix. See here, scalar matrix. The elements which are present in principal diagonal is equal and the next other elements are 0. It is a scalar matrix. For example, A is 2, 0, 0, 2. This is principal diagonal. The elements which are present in principal diagonal is equal and the other elements are 0. It is a scalar matrix. Next, identity matrix. See here, identity matrix or unit matrix. You can say it can call as unit matrix. In this matrix, the elements which are present in principal diagonal is 1 and the other elements are 0. It is called identity matrix. It is denoted with I. I equals to 1, 0, 0, 1. This is identity of matrix. The elements which are in principal diagonal is 1 and the rest of the other elements are 0. It is principal identity matrix. This order of this matrix is 2 by 2. And next, transpose of matrix. Transpose of matrix means interchanging the rows and columns. See here, transpose of matrix means transpose of matrix. Transpose of matrix means in a if a matrix obtained by interchanging the rows and columns, it is transpose of matrix. For example, A equals to 1, 2, 2, 0. Interchanging the rows and columns. A transpose is we will have to change this row into column 1, 2 and this row can be changed as column 2, 0. Here the row is changed as column and here the row is changed as column. This is A and this is A transpose. This is transpose of matrix. Next, symmetric matrix. Symmetric matrix. In symmetric matrix, if a matrix is equal to its A transpose, then it is called symmetric matrix. For example, this is one of the example of symmetric matrix. See here, 1, 2, 2, 2, 0 is a matrix. If we transpose this matrix and again it is equal to A transpose. This is A and this is equal to A transpose. 1, 2, 1, 2, 2, 0, 2, 0. This is symmetric matrices. And next, see skew symmetric matrix. What is skew symmetric matrix? In skew symmetric matrix, if a transpose of matrix it is equal to its additive inverse, it is skew symmetric matrix. For example, A equals to 0, minus 2, 2, 0. This is A. We have to do this A transpose. What it become? A transpose, row must be changed as columns. 0, minus 2, 2, minus 2. This is A transpose. We can find this A as, we can find this A inverse, additive inverse. In additive inverse, the signs must be changed. 0, minus 2 will become plus 2, plus 2 will become minus and 0. See here, the A transpose and additive inverse is equal. So, it is a skew symmetric matrix. Next, equality of matrix means, next we will learn equality of matrix. Equality of matrix means if a two matrices are equal with corresponding elements and the order of a matrix are also equal, then it is equality of matrix. For example, see here, equality of matrix. If a two matrix is equal with corresponding elements and the order of the matrix is equal, so it is a equality of matrix. See here, A equals to 1, 2, 3, 4 and B equal to 1, 2, 3, 4. Here the order of a matrix is 2 by 2. Here the order of matrix is 2 by 2. So, here how many rows? 2 rows, 2 columns. 2 rows, 2 columns. The order of matrix is equal. And the corresponding elements, corresponding means same position. In 2 matrix, same position. 1, 1, 2, 2, 3, 3, 4, 4. The corresponding elements are also equal. So, it is an equality of matrix. These all matrix we have learned these matrix in our 9th class only. Let us see some problems. Addition of matrix. If A equal to 2, 4, minus 6, 5, B equal to 4, minus 3, 5, 7, find 3A plus 2B. See friends, here we are finding the addition of matrix. What you have to find? 3A plus 2B. Before finding this, first of all we have to find 3A. 3A means 3 into A. 3 into what is the matrix of A here? 2, 4, minus 6, 5. We should multiply this matrix with 3. This type of matrix is called scalar multiplication matrix. See here, 3 into 2, 6, 3 into 4, 12, 3 into 6, minus 18, 3 into minus 6, minus 18, 3 into 5, 15. This is 3A matrix. Next we have to find 2B. 2B means 2 into B. We should multiply 2 matrix with B. 2 into what is B matrix? 4, minus 3, 5, 7. It is equal to this this matrix will be multiplied by 2. 4 2s are 8. 4 into minus 3, minus 6. 2 5s are 10. 2 7s are 14. This is 3A and 2B. What you have to find? 3A plus 2B. We have to find 3A plus 2B. Let us find 3A plus 2B. What is 3A here? 6, 12, minus 18, 15. Plus, what is 2B here? 8, minus 6, 10, 14. In addition of matrix, the corresponding elements are added. See here, what is the corresponding elements here? 6 plus 8, 12 minus 6, 18 minus 18 plus 10, 15 plus 14. See here, the corresponding elements are added. In addition of matrix, the corresponding elements are added. See here, 6 plus 8, 14, 12 minus 6, 6, minus 18 plus 10, what? Minus 8, 10 plus 14, 29. What is this? 3A plus 2B. The matrix of 3A plus 2B is 14, 6, minus 8, 29. This is the addition of matrix. By doing this problem, we had learnt scalar multiplication matrix and addition of matrix. Scalar multiplication matrix means what? If a matrix is multiplied with only one number, it is a scalar multiplication of matrix. Let us see another problem in order of matrix, finding the order of matrix. If A into 1, 1, 0, 2 equal to 1, 2 and 2, find order of matrix and matrix A. See here what they have given to find the order of matrix and matrix A. Here the product of these two matrices is 1, 2. Did you understand? The product of these matrices is 1, 2. Here means it is multiplicative possible. When does multiplication is possible? When the number of columns in first row is equal to the number of rows in second matrix then only the multiplication possible. Did you understand? When the columns of the first matrix is equal to the number of rows of the second matrix, then only multiplication is possible. Here how many rows? How many rows, friends? 2 rows. Means these rows is equal to the number of columns in first matrix. So the number of columns, A are 2. Next we have to find row matrix. Here the column is 2 and the order of matrix, this matrix is 2 into 2 and the order of the product matrix is 1 by 2. 1 row, 2 columns, 1 by 2. See friends, if you multiply this 2 by 2 matrix with 2 by 2, if we multiply 2 by 2 matrix with 2 by 2 matrix, the order of the product of the matrix is also 2 by 2, but we want 1 by 2 matrix. See here, if you multiply this 1 by 2 matrix with 2 by 2 matrix, the order of the product matrix is also 1 by 2 matrix. So the order of this matrix is, the order of matrix A is 1 by 2. Let us assume that A equals to, A equal to AB. Let us assume that A equal to AB, or not only AB. If you take XY, BX, what number you can, A equal to AB. Next you have to multiply A into this matrix. What is A here? AB into 1, 1, 0, 2 equal to 1, 2. When does multiplication is possible? When the number of columns in first row is equal to the number of rows in the second matrix is, then only the multiplication is possible. See here, how many rows, how many columns? 2 columns. This is first matrix. And here how many rows? 2 rows. This is second matrix. So they are equal. Then the multiplication is possible. See here, first row, first column, A into 1 plus B into 0. Next, first row, next column, A into 1 plus B into 2. Here the product of matrix is 1, 2. See here what? A into 1, A plus B into 0, 0. A into 1, A plus B into 2, 2B. Here the product of matrix is 1, 2. 1, 2. See friends, by the equality of matrix, the corresponding elements are equated. See here. See here what here? A plus 0, A plus 2B equal to 1, 2. By the order of matrix, the corresponding elements are equated. Here what? A equal to 1, A plus 2B equal to 2. By the order of matrix, we got A equal to 1. We have to, if we substitute A equal to 1 in A plus 2B, we can find the value of B easily. So we have to substitute A equal to 1 in A plus 2B. Substitute A equal to 1 in A plus 2B equal to 2. See friends, we have to substitute this A equal to 1 in A plus 2B equal to 2. What is A here? 1 plus 2B equal to 2. 2B equal to, this plus 1 will goes to right hand side. What it become? Minus 1. B equal to 1 by 2. So here the A is 1 and B is 1 by 2. Since we assume that A equals to, since we assume that A equal to AB, see here A equal to 1 and B equal to 1 by 2. So A equal to 1, 1 by 2. The order of matrix is 1 by 2. Did you understand? Friends, see here. When the product is given, then only the multiplication is possible. When the multiplication is possible, when the number of columns in first matrix is equal to the number of rows in the second matrix, then only the multiplication is possible. See here we assumed that A equals to AB and we multiplied that. We multiply means A plus 0, A plus 2B, 1, 2. The product of the matrix is 1, 2. We got this. By the equality of matrix, we equated. A equals to 1, A plus 2B equal to 2. By substituting A equal to 1 in A plus 2B, we can find B easily. So, we are substituting 1 plus 2B equal to 2, 2B equal to 2 minus 1, B equal to 1 by 2. Since we assumed that A equals to AB, so A equal to 1, 1 by 2. The order of matrix is 1 by 2. By doing this problem, we came to know the, we have learned how to find the order of matrix and the matrix. And let us see another problem. This is very interesting. See here. If A equal to 1, 4, 0 minus 1, B equal to 2, M, 0 minus 1 by 2. This is very interesting. Listen carefully, friends. Find M if AB equal to BA. They are given that AB equal to BA. So, let us find first AB equal to BA. To find M, we have to first find AB equal to BA. Let us find AB first. A into B. What is A into B? A and B. What is A matrix? 1, 4, 0 minus 1 into, what is B here? 2, M, 0 minus 1 by 2. See here, first row, first column, first row and second column. We should multiply like this. See here, 1 into 2, 2 plus 4 into 0, 0. 1 into M, M. 4 into minus 1 by 2, minus 4 by 2. See here, 4 into minus 1 by 2, minus 4 by 2. And next, 0 into second row, first column and second row, second column. 0 into 0, 0, minus 1 into 0, minus 0, 0 into M, 0, minus 1 into minus 1 by 2. What here become? Minus 1 into minus 1 by 2 plus 1 by 2. Here the AB is, therefore AB is 2, M minus 2 ones are 2 twos are, M minus 2, 0 plus 1 by 2. Next we have to find BA. BA equal to, what is B here? 2, M, 0 minus 1 by 2 into, what is A here? 1, 4, 0 minus 1 by 2. We should multiply like this. In a similar way, first row, first column and second column, second row, first column and second column. See here, 2 into 1, 2 plus M into 0, 0. Next 2 into 4, 8. M into minus 1, minus M. Minus M. 0 into 1, 0. Minus half into 0, minus 0. Is it or not? Not. Minus half into 0, minus 0. Minus 0 into 4, 0. Minus half into minus 1 plus 1 by 2. Here AB is 2, 8 minus M, 0, 1 by 2. What we have got? They have given that AB equal to 0. AB equal to BA. They have given that AB equal to BA. This is the equality of matrix. By the equality of matrix, what is AB here? What is AB? 2, M minus 2, 0 plus 1 by 2 equal to, what is BA here? 2, 8 minus M, 0, 1 by 2. This is the equality of matrix. By the equality of matrix, to find M, we should equate the equal corresponding elements. We should equate the corresponding elements. What is corresponding elements? 8 minus M and 2 minus 2 equal to 8 minus M. We should equate that two corresponding elements to find M. See here, by the equality of matrix m minus 2 equal to 8 minus m. To find m plus m. This minus will become plus sign. M plus m equal to 8 minus 2 will become plus 2. M plus m, 2m equals to 8 plus 2, 10. Therefore, m equals to 10 by 2. It means 2 ones are 2 5s are. Did you understand? Therefore, the value of m is 5. This is equality of matrix. See here friends, we have learned equality of matrix, and multiplication is matrix of multiplication is not commutative. It is only commutative in some special cases. See friends, other example, if this is inverse of matrix, if A equal to 1, 2, 1, 3, show that A inverse equal to 4i minus A. We have to show that A inverse equal to 4i minus A. When does inverse exist? Friends, when does inverse exist? To a non-singular matrix. Yeah, is it? To a non-singular matrix. What is non-singular matrix? Yes, you are correct. Very good. When does inverse exist to a non-singular matrix? If the determinant of matrix is not 0, it is a non-singular matrix. What is determinant of matrix? Determinant of matrix A is AD minus BC. If it equal to 0, it is a singular matrix. If it is not equal to 0, it is a non-singular matrix. The inverse exists to non-singular matrix. So, it is a non-singular matrix. Check to exist inverse, we have to check whether it is the inverse or it is a singular or non-singular. What is determinant of A here? AD minus BC. What is AD here? 3 into 1 3 minus BC 2 into 1 2. Therefore, 1. It is not equal to 0. So, it is a non-singular matrix. What is it? Non-singular matrix. What is it? Non-singular matrix. For a non-singular matrix, inverse exists. So, we have to find inverse now. What is, we already know that inverse is 1 by AD minus BC, D minus B minus C, A. This is inverse. Next we have to find inverse. What is AD minus BC here? 1. What is D here? 3. And what is B minus B? Here 2 minus 2. What is C here? Minus 1. Yes, right. What is A here? 1. Therefore, A inverse is 3 minus 2 minus 1 1. This is A inverse. Next we have to find, we have to show this here is given, show that A inverse equal to 4i minus A. We got A inverse and we have to do RHS. What is RHS here? 4i. What is I here? What is I means? Identity matrix. If the numbers of principal diagonal is 1, it is an identity matrix. So, identity matrix is 1 0 0 1. What is 4i matrix? What is 4i matrix? 4 into I 0 0 1. 4 into I means 4 into 1 4 0, 4 into 0 0, 4 into 1 4. This is 4i matrix. And next we have to subtract 4i minus A. 4i minus A equal to what is 4i? 4 0 0 4 minus what is the matrix of A here?